My voice is audible to all?
Yes, sir.
Okay. So now we will move to our last bit, that is principle of virtual work, that we will see, and then we will move to the next numerical. Okay. So here principle, there is no numerical on this principle will be asked in the examination. Just you need to see what is the principle, just definition is there and formula is there. Okay, maybe MCQ can be asked for 1 mark on this. So principle of virtual work. So virtual means imaginary. Virtual means it is not real, it is imaginary. So I will write first, if the body is in equilibrium, then the total work done by the system should be zero. Okay, so this is the principle of virtual work. If the body is in equilibrium, then the total work done by the system must be zero or should be zero. What is the formula for work done? You have studied in the physics also. Work done is equal to force into displacement. It is the work done which is equal to force into displacement. Okay, so work done, it is given as, we will write the formula, work done is equal to force into displacement. So in this way the work done is calculated. So when a system is in equilibrium, that is the resultant force acting on the system is zero, then the work done by the system must be zero. Okay, and work done, it is calculated as force into displacement. This is the formula for work done. Okay, when the force is given, work done is calculated like this. When the force is given, when the force is known to you, then work done, it is calculated as force into displacement. Okay, but instead of force, if the moment is acting, if the external moment is acting on the beam or on any structure, then work done is calculated as moment into angular displacement. Okay, then it is calculated as moment into angular displacement. So here in short form I can write W is equal to F into D, that is force into displacement. And if the moment is given, then this work done, it is calculated as work done is equal to moment into, instead of displacement we will take angular displacement. Instead of displacement, angular displacement is taken into the consideration. Angular displacement. So this is W is equal to M into theta. W is equal to M into theta. This is what we can call it as a principle of virtual work. Okay. So once again, I will tell you what is the principle of virtual work. When a system is in equilibrium, the total work is done by the system must be zero. That is what the principle of virtual work says. Okay. And this work done can be calculated as work done is equal to, if the forces are acting on the system, then this work done is calculated as W is equal to F into D, that is force into displacement. Okay. And if the moment is acting on the structure, or a moment is external moment is applied on any member, then the work done is calculated as W is equal to M into theta, that is moment into angular displacement. That is the moment into angular displacement. Okay. So this is the principle of the virtual work, which is the last bit of this unit. Okay. So maybe 1 mark MCQ questions can be asked on this. They may ask you the formula. What is the formula for the work done of the virtual work if the forces are acting on the structure? Then they will give you some options, and your formula will be W equal to F into D, or either W equal to M into theta if the moment is given. This type of question will be there. No numericals will be asked. As per the old syllabus, the numericals were also there on this virtual work, but right now it is removed. So only this theoretical part is there. Introductory. What is the virtual work? Its principle, that is the definition, and then formula. Okay. So with this now, our second unit is also over. Okay. Now we will start with the third unit. Okay. Yesterday I have told you to download one app. Have you done that?
Yes, sir.
Okay. So today we are not going to use that for the MCQ because I have not prepared the initial questions which I am going to give you. So tomorrow we will use that app. Okay. How many students are present right now? 46. Attendance is less. Those who are not there, if they are in your contact, they were absent, your friends are there, then tell them to install that app. Okay. It is Kahoot, Kahoot. Okay. On that we will solve the MCQs. So next is unit number 3. Unit 3, analysis of of pin jointed plane frames. Okay. So this is your unit number 3rd. So in this unit, basically we are going to see how to analyze the trusses. Okay. In this unit, we are going to see how to analyze the truss. Okay. Truss. So what is the truss? So if you visit the railway station, okay, if you visit the railway station, you can see that on the railway station there is no concrete slab over there. Okay. Most of the times on the railway station, if you see at the roof you will see the structure like this. It is provided like this. Okay. And some the geometrical arrangement, and those are steel bars, okay, which are placed like this type of structure you will see over there. And here on this it will go like beyond like this. Okay. And here the sheets are placed. Sheets means पत्रा टाकलेला असतं याच्यावरती. ते दोन्ही बाजूने असा पत्रा असतो. And this type of structure you will see. Now this is the arbitrary geometry which I have shown. There are many types of geometries. So this structure is known as truss. This structure is known as truss. बघा तुम्हाला कुठेही सापडेल किंवा sometimes in this also old मंगल कार्यालय जे होते ना, big halls, there also this type of structure is used. Okay. When you are not going to construct above it, okay, suppose now you are going to construct only first story and there will not be any construction above it, then in that case normally to avoid the expense of the slab, okay, if you are going for the RCC slab, then it will cost you more. Okay. So to avoid that, नॅचरली कॉन्क्रीट पेक्षा पत्रा तुम्हाला स्वस्तच भेटते, पण त्याला सपोर्ट करायसाठी हे जे खाली स्ट्रक्चर आहे, दिस टाइप ऑफ स्ट्रक्चर इज प्रोव्हाइडेड बिलो दॅट. ओके, दिस स्ट्रक्चर इज नोन ॲज द ट्रस. This structure is known as the truss. So this is the truss, and these are the different members of truss. Okay, these are the different members of truss. This total height, if I draw the neat diagram, then I will tell you the different members of the truss, what they used to be called. So first of all, we will draw one diagram. Suppose now this type of truss is there. This type of truss. Okay. So now the geometry of the truss is like this. This is the geometry of the truss. Geometry can be different. There are many types of geometries of the truss. They are depending upon the loading. What loading is coming on the truss, those are depending upon that. It is like this. Okay. This is the geometry of the truss. This is the geometry of the truss. Now this total height of the truss, this total height of the truss, this height, it is known as rise. This is known as rise. R-I-S-E. This is called as rise. Rise means the height of the truss. So this diagram, it is called as truss. Okay. It is used below that asbestos sheets, okay, to support them. This is the steel structure. Okay, and these all remaining are called as the members of the truss. These all are the members of the truss. Then all these see, these are the joints. These are called as joints, where all the members are meeting each other. These are called as joints. These all are joints which I am showing in yellow. Okay, these are joints. Now these are pin jointed. These all joints are pin jointed. Pin jointed means hinge support. Okay, pin jointed means what? Now suppose my two fingers are there like this, and if I insert anything in between these two fingers are like this, and if I insert, you can say a pen or anything, then these two fingers will not get separated, but they can rotate like this. Okay, they can rotate like this. Okay, so this type of support, that is pin support, is over there. So moment is allowed. Again, moment is allowed. It is not allowed to displace vertically. It is not allowed to displace horizontally. So at the hinge support or pin support, we will get two reactions. One is vertical, because vertical motion is restricted, and another reaction is horizontal. घेतो ना आपण हिंज सपोर्टला दोन रिएक्शन्स घेतो, एक वर्टिकल एक हॉरिझॉन्टल. कशामुळे घेतो? तर हिंज सपोर्टला आपण व्हर्टिकल मोशन रिस्ट्रिक्ट करतो, व्हर्टिकल मोशन अलाउड करत नाही, आणि हॉरिझॉन्टल मोशन पण अलाउड करत नाही एखाद्या मेंबरची. सो दॅट इज वाय वी टेक टू रिएक्शन्स ऍट द हिंज सपोर्ट. ओके, बट वी अलाउड द मोमेंट. म्हणून मग हिंज सपोर्टला आपण मोमेंट घेत नाही. मोमेंट आपण कुठे घेतो? फिक्स सपोर्टला घेतो, कारण फिक्स सपोर्टला आपण मोमेंट सुद्धा अलाउड करत नाही. ओके, so these all members which are meeting at a single point, those are pin jointed members. Okay, so those are pin jointed members. So this is called as rise. Then this member which is on the side, okay, so I will show this member. This is called as principal rafter. This member, this is called as principal rafter. Okay. This is called as principal rafter. This side also, because this member is just below the sheets. असे दोन मेंबर गेलेले आहेत आणि त्याच्यावरती असे पत्रे येणार आहेत वरून. दीज आर द टू मेंबर्स, त्याच्यावरती पत्रे येतील असे. ओके, सो दिस टू आर द कॉल्ड एज प्रिन्सिपल राफ्टर्स. These two are called as principal rafter. Okay, then the members which are over here, the members which are here inside, these are called as strut. These are called as strut. These members, okay, all these members. This is also called as strut. This is also called as strut. This is also strut. This member is also strut. Okay, then this member is also stud, this is also stud. And the members which are at the bottom at this location, okay, these are the members. So these members are called as tie members. These members are called as tie members. Generally, the strut members carries the compressive force and tie members carries tensile force. Generally, the strut members carries compressive force and the tie members carries tensile force. If I give name to this, then the naming will be A, B, C, D, E, F, G, H, I. So for any member, you can see this is member AB, this is member AI, this is member BI, this is member BH or HB, IB. Okay. So in this way, you can name the members and we have to analyze these members for the forces, which type of force is induced in that member. And we have to calculate the magnitude of that force which is induced in the member. And also we have to determine the nature of the force, whether it is compressive or it is tensile, whether it is compressive or it is tensile. Sign conventions which are used while analyzing this is if the force is tensile force. If the force is tensile force, then it is treated as positive. Okay. And if the force is compressive force, if the force is compressive force, then we take it as a negative. Then it is negative. Okay. So these are the sign conventions. These are the sign conventions while solving the numericals. We will use. While solving the numericals, these things we will see in the detail. Just for the overview, introductory point, I am telling you the things. And this distance, it is called as the span of the truss. Okay. So from this point A to point E, this is nothing but span of the truss. This is called as span. This is called as span. Okay. So this is the primary introduction about the truss. This geometry I have shown arbitrarily. There are many types of geometries. You can vary in the geometry depending upon the loading condition. That detail is not there for your syllabus. For your syllabus, they will give you the diagram of the truss and you have to analyze it. Diagram will be given in this unit. Okay. So it is not required that you have to design this. Just you have to analyze it. So these are the different types of members. Okay. So normally the members which are carries the tensile force are called as tie members. Members which are carry the compressive force are called as struts. Okay. Normally these horizontal members, which are horizontal members, are there at the bottom. Those are tie members, and other members are the strut. Other members are strut. Other members generally carries the compressive force, and these tie members carry the tensile force. Okay. And the member, after analyzing, suppose now I am analyzing this joint A. Okay. These are called as joints. These are all are the joints where a joint is a point where two or more than two members are meeting. Joint is a point where two or more than two numbers are meeting. Now I can say this A point as a joint because here at this A point, member AB and AI, two members are meeting. B point is also joint because at B point, BA, BH, and BA, BI, and BH, these three members are meeting. Okay. If I consider joint C, then at joint C, CB, CH, and CG, then CD. These are the four members are meeting at that joint C. So I can call this C as a joint. Okay. So while pronouncing the member, if I'm analyzing joint A, if I am analyzing joint A and I have calculated the force in this member AB, then if I am analyzing joint A, then I will call this member as AB. Joint name you should take first. Now joint name is A, so I will call this member as AB. But when I am analyzing the joint B, then same member AB, I will call it as BA because now I am analyzing the joint B and I am taking the force in member AB, but I am at joint B. So from joint B, I am doing some analysis. Then joint name should come first. So we will call this as BA. Okay. These nomenclatures we are going to follow while analyzing the trusses. This is the simple truss diagram which I have shown over here for the introductory part. Okay. Anything else you want to ask? where this practically, if you want to see this now, visit to railway station platforms of the railway station, where you can see that below that asbestos sheets म्हणजे पत्र्याची शीट्स असतात, त्याच्या खाली असं स्ट्रक्चर तुम्हाला बघायला मिळेल. Okay, steel structures. Okay, now foot over bridges. If you see the foot over bridges, now if you go on this Solapur Pune expressway, okay, near to Solapur University, near to Sinhagad College, you can see there is one footbridge to cross that road from this side to this side for the persons, for the human beings who are walking. Okay, and they want to cross the road from
वॉइस ब्रेक होते सर.
now you is my voice is breaking? Others?
No, sir.
No, sir.
Okay, so you ensure that you should be in a proper range, because I am in college here, broadband net is there right now. Okay, so there is no problem with the net from my side. And sometimes there you will get the breakup in the voice because of your range is not proper. So others are getting my voice without breaking. It means that you may facing some problem with the range. Okay, so please ensure that you are sitting in a place where the range is proper. So now coming back to our point, whenever the foot over bridge is there, suppose now a big highway is there, expressway is there, and person who is walking, he want to cross the road. So on the expressway, you know that the speed of vehicle is very high speed is there, and if you are crossing the road, it will become very risky. So in that case, they will the construction is made for a foot over bridge. It is called as foot over bridge. It is made up of steel. It is not made up of RCC. RCC is more expensive, and for dismantling also RCC structure, for dismantling जर ते पाडायचं असेल तर RCC स्ट्रक्चरला जास्त खर्च येतो. RCC स्ट्रक्चर म्हणजे कॉन्क्रीटचं स्ट्रक्चर, कॉन्क्रीट अँड स्टील बार्स. So they are made up of a structure of steel. There also you will see this type of arrangement. Okay, this is called as truss. कुठं बघायला मिळालं तर बघा, रेल्वे स्टेशनवरती तर 100% तुम्हाला दिसेल द प्लॅटफॉर्म्स ऑफ रेल्वे स्टेशन. किंवा तुम्ही एका प्लॅटफॉर्मवरून दुसऱ्या प्लॅटफॉर्मवरती जाता, ओके, त्यावेळेला जाताना सुद्धा तुम्ही ज्यावेळेला जिना चढून खाली दुसऱ्या जिन्याला उतरत असता, मधला जो पॅसेज आहे त्या पॅसेजच्या वर कधी बघा कसं स्ट्रक्चर दिलंय, काय दिलंय, पत्रे कसे ठेवलेले आहेत, कसं सपोर्ट दिलेले आहे. So there you will find this type of structure. This is called as truss. So again, rebrushing, these members are called as the principal rafters. These two members, above these two members, sheets are placed. ह्याच्यावरती पत्रे प्लेस केलेले असतात. Every point where two or more than two members are meeting is called as joint. Every joint is the pin jointed. Okay, and the members which are inside this geometry, which are vertical or inclined members, are normally called as struts. Normally they carry compressive force. The members which are bottom are called as tie members, because generally they carry tensile force. If the force is tensile, we treat it as a positive force. If the force is compressive, we treat it as a negative force. Okay, so this total height of the truss, it is called as rise. Instead of height, the word used rise. And this from A to E, whatever the distance is there, this is the total length of the truss. It is called as span. This is called as span of the truss. Okay, span means center to center distance. Okay, in the case of beams also we use this word span. Okay. So now this is the introductory part. So we are coming to the next bit, plane frame. Okay, plane frame. What is the plane frame and what is the space frame? Plane frame means what? Now this is the truss. Okay, so if you see, all the members of this truss are in a single plane. If I draw here the axis x and y, x axis, and here y axis, vertical is y, horizontal is like this x. So this truss will come in xy plane. So all the members of this truss are lying in the same plane. So this is called as plane frame. If all the members are lying in the same plane, okay, in a single plane, then it is called as the plane frame. And if all the members are not lying in the single plane, then it is called as the space frame. Then it is called as space frame. Okay. So we will write these two definitions. What is plane frame and space frame? So here first, plane frame. Plane frame. Okay. So a plane in which all the members lies in a single plane, is called as plane frames. Is called as plane frames. Very simple. Okay. आता तुम्हाला प्लेन्स माहिती आहेत काय असतात. XY plane we have discussed earlier in the unit number 1 also. XY plane, YZ plane, XZ plane. These are the different planes. Okay. So if a whole structure, so whole truss, all the members of a truss or all the members of a frame, if they are lying in a same plane, in a single plane, then those are called as plane frame. Very simple. Those are called as plane frame. Next is space frame. Next is space frame. Truss is also called as frame. Space frame. So here I should write a frame. I have written plane. Here a frame in which. Okay. So a frame in which all the members do not lie in a single plane, is called as space frame. Is called as space frame. Okay. So there are different types of frames. So that we will see now. The classification of frames. That is the types of frames. Types of frame. Types of frames. So basically the frames are divided into two types: perfect frame and imperfect frame. Perfect frame and imperfect frame. We will see later on which is perfect frame, which is imperfect frame. So basically there are two types of frames. One is the perfect frame, another is the imperfect frame. Perfect frame is not further divided into subtypes, but the imperfect frame is again divided into two types. First is the deficient frame and second is the redundant frame. Deficient frame and redundant frame. Now we will see everything one by one. It is very simple. Okay. So the frames, types of frame, it is divided into two types: perfect frame and imperfect frame. So first type is perfect frame. Perfect frame. And second is imperfect frame. Imperfect frame. Clear? Very simple. It is divided into two types: perfect frame and imperfect frame. Okay. So what is perfect frame now and what is imperfect frame? Okay. That we will see one by one. But for in general, I will tell you there is one equation. It is M is equal to 2j minus 3. M is equal to 2j minus 3, where M is equal to number of members. M is equal to number of members. So how many members are there? J is equal to number of joints. J is equal to number of joints. Okay. Now this M is your LHS and this 2j minus 3 is your RHS. Okay. So if any frame, if you get this LHS and RHS equal, if in any frame, if you get this equation satisfied, that is M is equal to 2j minus 3, M, whatever the number of members are there, that much for amount you will get over here also on the RHS. If it is equal, then it is called as perfect frame. Then it is called as the perfect frame. If it is not equal, then it is called as the imperfect frame. If it is not equal, then it is called as the imperfect frame. Okay, I will tell you one simple example. बघा आता समजा मी triangle draw केलं. Now this is a triangle. Okay, now I want to see that this triangle, whatever I have drawn, it is perfect frame or imperfect frame. That I want to determine. So I will give the name to this triangle A, B, C. Now my LHS is M. M is what? Number of members. How many number of members are there? AB, this is the first member. BC, it is the second member. And AC, this is the third member. So how many number of members are there? 3 members are there. Now 2j minus 3. This is my RHS, 2j minus 3, which is equal to, where 2 and 3 are the constant, but j is the number of joints. So what is the meaning of joint? I have already told you what is joint. Whenever 2 or more than 2 members, 2 or more than 2 members are meeting at a point, then that point is called as joint. Now here you can see at point A, this is joint, this is also joint. Okay, I will show over here. This is joint, this is also joint, and this is also joint. So how many joints are there? 1, 2, and 3 joints are there. So if I do 2j minus 3, so it is 2 into 3, 2j minus 3. Okay, so 3 into 2, 6, 6 minus 3, 3. So बघा दोन्ही सेम आलं. LHS is equal to RHS. So I can say that triangle is perfect frame. So I can say that triangle is perfect frame. समजलं कसं बघायचं perfect frame? Clear?
Yes, sir.
Yes, sir.
Okay, just you need to see that whether it is satisfying this equation M is equal to 2j minus 3, where M is number of members, J is number of joints. If this equation is satisfied, then you can say that if LHS and RHS are equal for a given frame, then you can say that this is a perfect frame. This is a perfect frame. मग आता imperfect frame म्हणजे काय असेल? तुम्ही सांगा बरं, imperfect frame म्हणजे काय असेल?
M is not equal to J.
Is equal to not equal to RHS.
Correct, correct. So M is not equal to 2j minus 3. It means that it is an imperfect frame. आता बघा साधी गोष्ट आहे. M हे 2j minus 3 ला इक्वल करत नाही, म्हणजे इम्परफेक्ट फ्रेम आहे. मग इम्परफेक्ट फ्रेमचे किती टाइप्स असायला पाहिजेत? 2 टाइप असायला पाहिजेत. ह्याच्यामध्ये 2च कंडिशन तुम्हाला मिळणार आहेत. काय कंडिशन मिळणार आहेत? जर M म्हणजे LHS ही जर RHS ला इक्वल करत नसेल तर 2च कंडिशन असणार आहे. एक तर LHS ही RHS पेक्षा काय असायला पाहिजे? ग्रेटर, और LHS ही RHS पेक्षा काय असायला पाहिजे? लेस. बरोबर आहे ना? नॉट इक्वल टू चा अर्थ हेच होतं ना, एक तर एक साइड लहान असणार आहे किंवा दुसरी साइड लहान असणार आहे. So here I can say that LHS means either M is greater than 2j minus 3 or either M is less than 2j minus 3. These are the two cases. So that is why imperfect frame is again divided into 2 types. Okay. Are you getting my point? Whenever you say that it is a perfect frame, it means that it satisfies the equation M is equal to 2j minus 3. This equation is satisfied. Okay. Then we will call it as a perfect frame. But when you are called this as an imperfect frame, when your M is not equal to 2j minus 3, मग not equal to चा अर्थ काय? Not equal to म्हणजे काय? एक तर M हा 2j minus 3 पेक्षा मोठा असायला पाहिजे, बरोबर? नाहीतर M हा 2j minus 3 पेक्षा लहान असायला पाहिजे. त्याचाच अर्थ झाला नॉट इक्वल टू. इक्वल टू म्हणलं तर तुम्ही या केसमध्ये आला. ओके, सो बेस्ड ऑन दिस इक्वेशन the imperfect frame is again divided into 2 types. Okay, so now we will see further one by one. I will erase this. Okay. So further, while describing this, we will see each case one by one. With example, we will see. Just for your understanding, I have covered the introductory part. Okay, so you will be able to understand what is the exact meaning of perfect frame and imperfect frame. So perfect frame. So here I will write in bracket. It is m is equal to 2j minus 3. This is the perfect frame. And for imperfect frame, it is again divided into two types, but it is m is not equal to 2j minus 3. This is the equation. This you should remember, this equation. Okay. So therefore, if this imperfect frame is again divided into two types, and those two types are deficient frame and redundant frame. Deficient frame and redundant frame. So this is called again divided into two types, deficient frame. Deficient frame and redundant frame. Redundant frame. Okay. So for the deficient frame, your equation is when m is less than 2j minus 3. Deficiency म्हणजे कमतरता. Deficiency means कमी. Okay. So deficient frame means m is less than 2j minus 3. So it is called as deficient frame. And for the redundant frame, m is greater than 2j minus 3. M is greater than 2j minus 3. So these are the various types of frames based on this equation. The equation is m is equal to 2j minus 3. We have to just check LHS and RHS. Accordingly, we will classify. आता समजा तुम्हाला एखादी फ्रेम दिलेली आहे, ओके, आणि तुम्ही हे इक्वेशन चेक केलं. इफ यू चेक दिस इक्वेशन m is equal to 2j minus 3, you first you have taken LHS. Suppose you got m is equal to 10, number of members 10. Okay, then you have taken RHS, you calculate 2j minus 3, and if you get this 2j minus 3 is equal to 15. Suppose now your m is 10 and 2j minus 3 is 15. So your m is less than 2j minus 3. So you can say that this frame is the deficient frame. After solving, you can say that this frame is the deficient frame. In the MCQ also, they may ask you this type of question. Okay, they may give you a small frame and they will ask you which type of frame it is. And they will give you these four options: perfect, imperfect, deficient, redundant. So based on this equation, you have to choose the correct answer, whatever may be the correct answer. Okay. So now we will see each frame in detail. First, we will see the perfect frame. Is there any doubt in this? Whatever equations I have written over here. समजलं ना काय सांगितले ते?
Yes, sir.
Okay. So now we will see each frame detail one by one. Okay. Perfect frame. First is the perfect frame. We will take one example of each frame so that it will become clear to you. First of all, I will write in the perfect frame the frame which satisfies the equation m is equal to 2j minus 3 is called as perfect frame. Okay, this I have already told you what is the perfect frame. So now we will take the example of the triangle. So I will write consider the frame shown below. Now consider this frame. So I will draw the frame. So this is the frame which we are considering right now. This is the frame. Okay. So in this frame now, I will give the name A, B, and C. So number of members. So we will calculate number of members. So number of members. Number of members. We called it them as M. How many number of members are there? 1, 2, and 3. 3 members are there. Okay. So 3 I will write. 3 members. Then we will call number of joints. Number of joints. How many joints are there? Number of joints means J. So how many joints are there? 1, 2, and 3. So joints are also 3. Okay. So we will calculate now LHS. LHS is equal to left hand side is equal to M is equal to 3. This is LHS. RHS is equal to, it is 2J minus 3, which is equal to 2 into 3 minus 3, which is again equal to 3. Okay. So hence we can say over here LHS left hand side is equal to right hand side RHS. LHS is equal to RHS. So what is the meaning of this? Here I will write the equation. The equation M is equal to 2J minus 3 is satisfied by the given frame, by the frame shown in figure, by the frame shown in figure. Okay. Therefore the given frame, is perfect frame. Is perfect frame. Any doubt in this? Anybody is having any doubt in this perfect frame?
No, sir.
Okay. So if you are not having any doubt, we will take next. Next is the imperfect frame. Next heading is imperfect frame. So I have already told you imperfect frame means here M is not equal to 2J minus 3. Okay. That is your imperfect frame. Here I can write the frame which do not satisfy the equation, M is equal to 2J minus 3. So which do not satisfy the level is called as imperfect frame. Is called as imperfect frame. Okay. So it is divided into two parts. You also write down with me. It is divided into two parts. These are important notes for the MCQ. These are very handy notes. If you read these ones, you can answer any MCQ which will be asked on this. Okay. So it is divided into two parts. First part is deficient frame. The first type is deficient frame. So deficient frame is what? Here M is less than 2J minus 3. That is deficiency. And second, redundant frame. So here M is greater than 2J minus 3. M is greater than 2J minus 3. Now this we will see in detail one by one. So first I will take deficient frame. Okay, that is M is less than 2J minus 3. This is the deficient frame. So now here I'll write the number of members. The number of members. What we have discussed, that only I am going to write over here. If the number of members M is less than 2j minus 3. If the number of members is less than 2j minus 3, then this type of frame is called as deficient frame. This type of frame is called as deficient frame. Okay. So consider a frame. Consider a frame shown below. Consider a frame shown below. Now we will see one frame. Now this is a frame. So I will call this as A, B. I will name this as A, B, C, D. The same thing we are going to do. Number of members. First of all, I will calculate number of members. Number of members. How many number of members are there? If we count AB, one member, BC, second member, CD, third member, and AD or DA is the fourth member. So how many members are there? Number of members M is equal to, it is 4. Then number of joints we will calculate. Number of joints J is equal to, number of joints J is equal to. So how many joints are there? See, whenever 2 or more than 2 members are meeting at a point, then that point is called as joint. So here you can see point A is joint. जेव्हा 2 किंवा 2 पेक्षा अधिक मेंबर्स हे एका पॉइंट वरती येऊन मिळतात तर त्या पॉइंटला म्हणायचं जॉइंट. सो दिस इज जॉइंट A, joint B, second joint C is the third joint B is the fourth joint. So how many joints are there? 4 joints are there. 4 joints are there. Now here LHS. So I will calculate the LHS now. LHS is equal to M is equal to how much? 4. Then RHS of the equation is 2j minus 3, which is equal to how much? 4 into 2, 8. 8 minus 3, 5. एवढं साधं कॅल्क्युलेशन कळतं ना डायरेक्ट. जे ची व्हॅल्यू किती आहे? 4. जॉइंट्स किती आहेत? 4. तर मी ते जे च्या ऐवजी 4 ठेवली व्हॅल्यू. 4 into 2 किती होईल? 8. 8 minus 3 किती राहिलं? 5. So here you can see your LHS left hand side, that is LHS M, it is less than your RHS. RHS is 2j minus 3. Okay, that you will see. So therefore the equation M is less than 2j minus 3 is satisfied by the frame shown in figure. Okay, frame shown in figure. Therefore the given frame is deficient frame. Okay, so just see this, and if you are having any problem, let me know. If no problem, we will move to the next frame. Any problem?
No, sir.
Okay.
No, sir.
Okay. So last one is the redundant frame. redundant frame. Okay, so redundant frame, m is greater than 2j minus 3. Same thing, m is greater than 2j minus 3. मागच्या वेळेस लेस होता आता greater. Okay, the number of members m is greater than 2j minus 3, then this type of frame is called as a redundant frame. Okay, it's called as redundant frame. So consider the frame shown below. Now the example of redundant frame. Consider the frame shown below. Consider the frame shown below. So here I will draw the frame. Now this is the frame. Now in this is my one diagonal. I am joining the diagonal. Okay. So where is my joint now? See, my first joint is this point. Let us call this as joint A. Second joint is joint B. Third joint is joint C. Fourth joint is joint D. Okay. And now I will draw another diagonal. So another member DB. So here you can see, here the joint is not provided. Huh? Just two members are crossing to each other. Here joint is not provided. Here the pin is not provided. So this members is just two members are crossing to each other like this, and the pin is not provided over here. Okay, so they will not able to rotate like this. Just one member is moving in this direction, another member is moving in this direction. Okay, so that is why I have already marked here the joints. This is not a joint. Just two members are crossing over each other. Okay, नाहीतर प्रत्येक ठिकाणी असं दिसलं की लगेच त्याला जॉईंट म्हणायचं नाही. If this is a joint, they may specify you in the problem. These two members are crossing to each other and this is a joint. Okay, but these types of simple problems will not be asked in the examination. So these are the two separate members. So now here, if I calculate number of members, m is equal to how many number of members are there? AB.
Six.
Correct. 6. AB first, BC second, CD third, DA fourth, AC is fifth, and DB is sixth. Okay. So 6 members are there. Number of joints. A, B, C, D. 4 joints are there. So LHS is equal to M is equal to 6. RHS is equal to 2J minus 3, which is equal to 2 into 4 minus 3, which is equal to 5. So here your M is greater than 2J minus 3. Okay, so here you can write your LHS left hand side, that is M, is greater than RHS, that is 2J minus 3. Okay, that is 2J minus 3. So the equation, which equation is satisfied now? The equation M is greater than 2J minus 3 is satisfied by the frame shown in figure. Shown in figure. Stop. Therefore, the given frame, is a redundant frame. Okay. So the given frame is redundant. Okay. So it is very simple. So today I think time is over. We will stop over here. Continue.
Kahoot app Kahoot app.
Your voice is breaking. Whatever app you have downloaded, that Kahoot, keep it with you. We are going to use that app later on. Okay, maybe tomorrow or day after tomorrow. Okay. Once I set the question bank for you, then we are going to use that app. Lively, all of you can able to give the answers by using that. Kahoot information, what information you want? Kahoot is just an app, you have to download it from the Google Play Store, and if you want additional information, go to YouTube and search the videos how to use the Kahoot app as a student. In the last lecture already I have told you. Now from here onwards, little bit, make a habit of self-study also. Okay, while using that app, I will tell you how to use that, but I will tell you while we are using that app. Now, right now, if you want more information about it, you can search on YouTube. So many videos are there regarding that app. Okay, so you can download it from the Google Store and you can go to YouTube and search that how to use the Kahoot app as a student, how to register on the Kahoot, what are the requirements to register on the Kahoot. Likewise, you will get so many videos, and you will get it clear. Okay, so now we will take the attendance. Okay, so today is what date?
15 February.
15th February. Okay. 15th Feb. PM. 1 to 11. Roll number 1,
Present.
2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present.
10, 11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present.
17,
Present, sir.
18. Roll number 18. Who is roll number 18? She is absent for so many lectures. If anybody knows, ask her to attend the lecture. Okay. 18, 19,
Present.
20. Roll number 20, 20. 21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31, 32, 33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36, 37,
Present at 36.
38,
Present, sir.
39, Present, sir. 40. Roll number 40, 40. 41.
Present.
42. 42. 43.
Present, sir.
44.
Present, sir.
45.
Present, sir.
46. 46 is present. Okay. 47.
Present, sir.
48.
Present.
49.
Present, sir.
50.
Present, sir.
51.
Present, sir.
52.
Present, sir.
53. 53. 54. Roll number 54. 55.
Present, sir.
56.
Present.
57.
Present, sir.
58. Roll number 58.
Present, sir.
Okay. 59.
Present, sir.
60. Roll number 60. 60. 61.
Present, sir.
Okay. So I will announce absent roll numbers once again. If your roll number is there in the absent list and you are present over here, you can tell me. Okay. Roll number 18, 18 is absent. Roll number 20. After that 40, 40. 42, 40 is present. Okay, 40 is present. Then 42, 54. After 42, 54. And then 60, 60. So these are the roll numbers which are absent today. All others are present. Okay, so now we will stop over here for today.